Hello everyone, my name is Tejas Bhansali and I welcome you all to my channel EduMech, where I post some interesting videos about science and engineering. So today's topic is Hydrogen Spectral Series. So basically, when an atom transfers from higher energy levels to the lower energy levels, some amount of energy is emitted or absorbed with certain wavelength. We will see those energy emissions and wavelengths with the help of a graph which contains, or mark my words, we are here explicitly talking about only and only hydrogen atoms. We are not focusing on other elements, only our focus will be on hydrogen. So let us proceed towards the graph. So you can see the first series of hydrogen atom is the Lyman series, where the energy levels are from n equals to 2, when the energy levels are from n equal to 1 to n equal to 7. Okay, so an electron or an atom of hydrogen may jump from this energy level to this energy level, or from 3 to 1, 4 to 1, and from 7 to 1. This is the ground state. This is the ground state. You can see that this is the n equals to 1 is the ground state in case of Lyman series, and it can last up to infinity, but for sake of understanding I have taken it up to n equals to 7. Okay, also for Balmer series you can see that the ground state is at n equals to 2 and it starts from n equal to 7. So whenever an electron or atom of hydrogen will jump from n equal to 7 to n equal to 2 or any of the levels, some amount of energy will be absorbed or emitted. So there are 6 kind of series: Lyman series, Balmer series, Paschen series, Brackett series, Pfund series, and the Humphrey series. Okay. As we go from n equals to 1 to n equal to 2 to n equal to 7, the energy levels will increase. So in short, as we proceed over positive y-axis, the energy level of the hydrogen will increase. So this energy difference between the levels and hence the wavelengths of emitted photons or atoms of hydrogen is given by Rydberg's formula, which is given by 1 by lambda is equals to r infinity z square in bracket 1 minus n1 square 1 upon n1 square minus 1 upon n2 square. And mind you, n1 should be less than n2, as it is natural law it is a law of nature. Anything falls from higher energy to lower energy. Okay, now where lambda is the wavelength of emission, r infinity is Rydberg's constant, and for hydrogen its value is 1.09667 into 10 to power 7. Z is the atomic number. Here we are talking explicitly about hydrogen, so for it Z is equals to 1. N1 is the lower energy level in a series and N2 is higher energy level in series, and for in each and every series an atom will fall from higher energy level to the lower energy level. Okay, now from equation 1, that is this equation of wavelength, we know very well the Max Planck equation, E is equal to h mu and mu is equal to c by lambda. So delta E is hc by lambda or equal to hu. This is called as Max Planck equation. Okay, and this is the conversion unit of energy. That's 1 electron volt is equal to 1.6 into 10 to power minus 19 joules. 1 electron volt is equal to 1.6 into 10 to power minus 19 joule, where H is again the Planck's constant. Its value is 6.626 into 10 to power minus 34. C is light speed in air, 3 into 10 to power 8 meter per second. Lambda wavelength and V is the frequency. Now let us try to solve few examples. Okay, first one is find the wavelength of first two emissions in the Lyman series of hydrogen and hence find energy emissions. So for first emission in Lyman series, as we all know from the graph, that the first two emissions in Lyman series are from n equals to 2 to n equals to 1 and from n equals to 3 to n equals to 1. So for the first emission, n1 is equal to 1 and n2 equals to 2. So by Rydberg's formula, 1 by lambda is equal to r infinity z square into 1 by n1 square minus 1 by n2 square. So putting all the values, n1 equals to 1, n2 equals to 2, it is, and r is equal to 1.09667 into 10 to power 7. Z is equal to 1 because the atomic number of hydrogen is equal to 1. So lambda comes out to be 1.21 into 10 to power minus 7 meter, which is equals to 121 nanometer, and 1 meter is equal to 10 to power minus 9, plus 9 nanometer. So energy emissions delta E is equal to hc by lambda. H is the value of Planck's constant, 6.62 into 10 to power minus 34 into C. Light speed 3 into 10 to power 8 upon lambda, the value which we got in above equation, and mind you, this lambda must be in meter. So delta E is equal to 1.642 into 10 to power minus 18 joule on solving this equation, and you have to convert this into electron volts. So by multiplying or by using this equation or this conversion rule, we can get the value of energy in electron volt from joule, which is equal to 10.26 electron volts. And as I told you earlier, for second emission, n1 is equal to 1 and n2 equals to 3. So again, using that same formula, 1 by lambda is equal to z square r infinity into 1 by n1 square minus 1 by n2 square. Putting all the values in the equation, we get lambda is equal to 1.02 into 10 to power minus 7 meter, which is equals to 102 nanometer. And energy emissions delta E is equal to hc by lambda. And again, putting all the values, you get value of delta E as 1.94 into 10 to power minus 18 joule, or delta E is equal to 12.18 electron volt by multiplying, or by using the relation 1 electron volt is equal to 1.6 into 10 to power minus 19 joule. Next numerical, find the wavelength of emissions in Paschen series till n equals to 7. So we have to find all the wavelengths involved in Paschen series. So let us see from where does the Paschen series start. So the Paschen series will start from n is equals to 3. N is equal to 3. Okay. So an electron or atom may fall from fourth energy level. So 1 by lambda. Now I have directly put the values. So this is 9 is 3 square and 16 is 4 square. So when an atom will fall from fourth energy level to third energy level, so lambda will be 1.875 into 10 to power minus 16 meter, or it will be 1875 nanometer. This is the first wavelength of the Paschen series. Next one, using same equation now, it will fall from n equals to fifth to third energy level as seen in the graph. So just 1 by lambda, or sorry, lambda is equal to 1.282 into 10 to power minus 6 meter, or 1282 nanometer will be the wavelength. Next energy level in the Paschen series will be 1 by lambda is equal to 1.09667 into 10 to power 7 is into, and it will fall from 6th energy level to 3rd energy level, and you will get the value of wavelength as 1094 nanometer. And last one, it will fall from 7th energy level to 3rd energy level, so the lambda will be 1005 nanometer. As you can see from the equations that when the atom is falling from 4th to 3rd and 5th to 3rd and subsequently till 7th to 3rd one, the wavelength of the emission is decreasing, because see, as one in first case from 4 n equal to 4 to 3 it was 1875, and when it falls from 5 to 3 wavelength will be decreased 1282 nanometer, and again 6 to 3rd it will be 1094, and subsequently from n equals 7 to n equals 3 1005 nanometer. So you can see that the wavelength is decreasing when an atom falls from higher energy level. Okay, last equation or last question, numerical. Find the energy emission in Humphrey series. So again using the same formula, 1 by lambda is equal to z square r infinity into 1 by n1 square minus 1 by n2 square. Let us again refer the graph to find out the values of n1 and n2 for Humphrey series. So you can see that for Humphrey series there is only one emission which is falling from n equal to 7 to n equals to 6. Okay. So the values of n1 and n2 will be 6 and 7 for Humphrey series. So using the formula 1 by lambda is equal to 1 into 1 atomic number into 1.09667 into 10 to the power 7 into bracket. So hence, since it is falling from 7th level to 6th level, so n1 equal to 6 and n2 equal to 7. So lambda will be given or found as 1.2373 into 10 to power minus 5 meter. Okay, and now using the formula, Max Planck formula, delta E is equal to hc by lambda. So h is equal to 6.626 into 10 to power minus 34 into light speed upon wavelength, which we got here. So delta E is equal to 1.6065 into 10 to power minus 20 joule, and on converting it to electron volts, it is delta E is equal to 0.1004 electron volt. So thank you for watching this video. If you want more such videos, kindly like this video, share this video and subscribe to my channel, and kindly hit that bell icon, so whenever I will post the video you will get the notification of it. Thank you.